Hey everyone, welcome back. Today we're going to talk about the addition property of equality. What the addition property of equality says is, if you have the ability to add the exact same rational number to both sides of an equation and get an equivalent equation. Basically, if you have two numbers that equal each other, in this case x and y, then if you add the exact same number to both sides of the equation, you will still get an equal equation. What does that mean? It means if you have two numbers, let's say 3 and 3, we agree that they equal each other. So what if we add the exact same number to both sides of the equation, in this case 4 and 4? 3 plus 4 is 7, so we get 7 and 7. And I hope everyone agrees that 7 equals 7. So this is basically the addition property of equality. And we can use this in a lot of different ways. The first way we're going to use it is with our one-step algebra. We have this problem, x plus 6 equals 9. And we want to draw the picture so you can see what it looks like. You'll notice that I have x here, and because we're adding on the 6, I have a 6 being added on right next to the x. And because that equals 9, we get another line that equals 9. So in algebra, the goal is to isolate the variable. I like to say get the letter by itself. So how in the world can I get this x isolated? How can I get it by itself? Well, basically, all I have to do is take away the 6. Well, I think you'll notice that the lines aren't equal anymore. So if I took 6 away from one side, I have to take 6 away from the other line, just to make it equal. And there it goes. So, what did we do here? We subtracted 6 from both sides of the equation. Basically, I took 6 away from one side and I took 6 away from the other. You'll notice that this side became x plus 0 or x plus nothing. And in essence, the other side became 3. And that's how we know that x equals 3. Of course, we can always check our work by plugging the x back into the original equation and realizing that 3 plus 6 equals 9. Now I know this is a very basic equation, but this is everything that we do for one-step algebra. The rules never change. So here's something I saw in our book, and I wanted to make sure to put it on there so that you guys, if you're looking at the book, could look at it as well. Here is, again, x represented by the purple rectangle plus 6 equals 9. We know it equals because they're all balanced. So here's our problem. So if I want to find out what x equals, what I have to do is to get the variable by itself, I take away 6. And now notice the x is by itself. But if I didn't take away 6 from the other side, it would not stay balanced. So I take away 6 from here. And hopefully everyone can see that when I take away 6 from both sides, that x equals 3. Make sense? Let's see some common mistakes. A lot of people will just start taking away numbers from either side. So what if I were to take away 6 from this side, but not take away 6 from the other side? I hope everyone notices that what would happen is one side gets too heavy and we lose our balance. So if I take 6 away from one side but not the other, it does not get me the answer that I want. Wrong. The other popular mistake that people make is, why can't I take the 9 away? Well, you can take the 9 away, but if I take the 9 away, check it out. I don't have 9 on the other side to be able to take away, so I'm in a problem. Once again, if I take 9 away, we're not balanced anymore, and you'll see that we get crushed. Anyway, so we are wrong again. The best way to do this is to always take away the number that is right next to the variable. That's how you isolate the variable and get the variable by itself. If you're looking at an equation without the picture, you would notice that someone would simply look to say, hey, x plus 6 equals 9. How do I get the x isolated? I subtract 6 from both sides. When I do that, I get x plus 0 equals 3, and x plus nothing is just x itself. There are people that will like to be able to do this sideways, and I fully allow this, where you just take the 6 away sideways. I call this typewriter style, because everything goes perfectly level. Notice we get x plus 0 again, and once again we get x equals 3, the exact same answer. For more advanced students, people might like to try and do what's called decomposing, where you break apart the 9 into a 3 plus 6, and then when you take away 6 from both sides, you'll notice you get zeros on both sides. And basically you get x plus 0 equals 3 plus 0, and again x equals 3. Any of these you can check and you will make sure you got the right answer. So, here's something that happens with some students. They get so used to the variable being on one side of the equation, what happens if I move the variable over to the right side of the equation? Does this change anything we do? Well, if you understand the picture, you'll notice to isolate the variable, we need to subtract the 6. And so, if I take the 6 away from this side, I have to take the 6 away from this side. That keeps it balanced. So even though we move the variable from the left side to the right side, we still take 6 away from both sides. And x would still equal 3. So if I have the variable on the other side, which number do I need to eliminate? Which number do I need to take away in order to isolate the variable? The -4 or the 3? You're correct, the 3. And 3 minus 3 is 0. So if I take away 3 from both sides, I end up getting x equals -7. Once again, if you like to go sideways, I have no problem with that at all. You will still get the exact same answer. And if you want to try the decomposing, this one is a little bit trickier, as you had to turn -4 into -7 plus 3, but it still works perfectly. As always, check your answer, because you will find that -4 does equal -7 plus 3. I told you that rules in algebra never change, so what if I have a fraction? Can I do the exact same thing? Absolutely. To isolate the variable, I need to eliminate the -4/5. I do that with a +4/5 because -4/5 plus +4/5 is 0. And then I just have to add these fractions. Not as easy as adding the other numbers, so don't be afraid to do your work off to the side. Get a common denominator and then add the numerators together. For 8th graders, I do not mind the answer being an improper fraction, but just so you know, I would also take 1 2/15 as my answer. Mr. Thomas, can I still go sideways? Absolutely. You just got your 0 pair there, and then you still have to add those fractions. And you still get the exact same answer. What about decimals? Do I have to do anything different for decimals? Of course not. To isolate the variable, all I need to do is add 6.88 to both sides, because -6.88 plus +6.88 equals 0, and I get the variable by itself. Once again, don't be afraid to do the work off to the side. The biggest mistakes people make is when they try and do too much in their head. So as I've tried to say, the rules for algebra never change. That's why I like the math subject so much. And the addition property will work with integers, rational numbers, and even variables when we get higher up into algebra. So, I hope you enjoyed this. If you have any questions for me, please let me know, and you guys have a great day.